One of the main arguments of flat earthers inevitably is that they tend to always use the phrase perspective, the rule of perspective, or the law of perspective. But what is that really? And does that really work? Let's take a look. Hi, I'm Michael, and this is Mike's Basement. If you have ever debated with flat earthers, chances are that the argument of perspective has come up once or twice, or maybe more. But the problem is that even though you look at the arguments that they make and think to yourself, yeah, okay, I can see where you're going. Something is nagging, right? Something is not right in that argument. And I have to say, you are completely accurate. So what is the argument? Let's first take a look at a video that I watched yesterday. I wanted to find some examples of flat earthers using exactly that perspective argument. And I found this guy called Peabrains, yes, that is actually his name, making this claim.
Calculate visual angles to convergent positions, which is where the sun is from the observer, by using non-convergent parallel lines.
Non-converging parallel lines. Try to say that again with me loudly. Non-converging parallel lines. Can you see the problem there? I can. Let's look at it. Now, I'm not an expert mathematician. In reality, I'm not a mathematician, I'm a physicist. So there might be some obscure mathematical world or some geometrical system where parallel lines do indeed converge. But if you think of the main argument, the argument in itself, converging parallel lines, it doesn't make sense. Parallel lines will, at least in a Cartesian flat coordinate system, will never converge. That is why they are parallel. That's the meaning of parallel lines. So as you can see and I know, yes, this was low-hanging fruits, but just to give you an idea of how flat earthers use these arguments. But let's go on. Let's talk a little bit about what perspective actually is. It might come as a surprise to you that within science, we don't really have a concept of perspective. When I talk with my astronomer buddies, when I talk with my professors, my teachers at the university, and we talked about how little or how big a galaxy or a star was when we observed it, we didn't say, yeah, that's because of perspective. In science, there is no real concept of perspective. There really isn't. But we do have something that is similar to perspective. So let's take a basic look at what perspective is from, let's say, an everyday point of view. Here I have this is my son little Lego man here. I have borrowed him. And as you can see, perspective is the fact that we live in a three-dimensional world, which means that we have an height. We usually denote that the y-axis. We have width or length in this direction here. We usually denote that the x-axis. And then we also have depth of vision, which is what we usually denote the z or z-axis. So one of the consequences of living in a three-dimensional world is that when you look at something like this little Lego man here, if I move him closer to you, he will seem to get larger. And if I move him away from you, he will seem to get smaller. But the reality of the world is that this little Lego man here, even though his apparent size seems to change, he doesn't really change his physical size. He doesn't actually get smaller when I take him further away from the camera than he was when he was close to the camera. So one key word here that I mentioned was apparent size. In science, and particularly in astronomy, we usually talk about exactly that, apparent size. We also talk about something a little more scientific. We call it angular size. An angular size, you can think of that if you have ever attended high school math. You have hopefully also seen the sine, cosine, and tangent rules. And one of the first exercises that I did in high school with respect to these rules here was, imagine yourself that you are standing on a large field, flat field, with one tree sticking up. Now you have a relatively short measurement tape. You can use that to measure the length, but it is not long enough for you to measure the height of the tree. But you also have an instrument to measure angles with. So what you can do then is to use the tangent rule. If you measure the length from one point to the tree and then measure the angle from the ground and up to the top of the tree, then using the angle and using the length to the tree from that point where you measured the angle, you can use the tangent rule to find the height of the tree, how tall the tree is. And one of the concepts that we use a lot in astronomy is the concept of parallax. Now, parallax is essentially when you look at a star and you compare it with the background stars, then if you see that star move a little bit, that is parallax. It is exactly the same as if you take the Lego man here again and hold him up out in stretched arm like this, and then you blink your eyes like this, then you will see that the Lego man apparently changes his position. Now, of course, he doesn't change his position, but the angle at which I was looking at him from one eye to the other, that is changing. One other way is that if we reverse the idea of parallax, let's say we know the angular size of something and we know the distance to that object, then just like with the tree, we can find how big that object is in space. So from a scientific point of view, what perspective really is the change of the angular size, or the apparent size, if you will, with distance. As something gets further away from you, its angular size or apparent size will diminish, but its physical size remains the same. So let's take another example from Peabrains, where he tries to tell us why we can't really use these parallel lines and have to use these converging lines instead, because that is his basic argument.
But it's a non-perspective side view representation. So this diagram is not accurate at all as it relates to the perspective of the observer. So if we add perspective lines, we get a completely different picture. All right, take a look at this wall of lines. Now, this wall is not an illustration, it's not a cartoon, it's a photo, it's reality, okay? This that they put up here, although it has a lot of truth, in it, showing the parallel sun and all that, it's nothing but some geometry. I mean, they're showing us some angles, but it has nothing to do with perspective and how we would see the sun. So, it's bunk. So in this next slide here, I'm going to superimpose these lines, the perspective lines, over on top of this. Okay, here we go. All right, and as you can see, the way they're representing the sun as staying parallel to the ground is not correct. The sun would follow these perspective lines, and what they really are is spatial planes, right?
So hopefully you can see what the problem is here. And I would say this is, to some extent, a general problem with flat earthers when they use this perspective argument, that they mix what we see in reality and how reality actually is. Now, I hope that most flat earthers know that what they see in reality doesn't actually change reality. Just like the example with the Lego man, just because he seems to change his size as I move him away from me, he doesn't actually change his size. He doesn't become smaller. Now, Peabrains' problem here is basically the same. It seems that he thinks that we can use these measurements. He says we look at it from the side, and that is correct. We can use that Because in reality, when we look at something, it seems that what we see, if we look at some parallel lines, there you have it, right? They seem to converge. But the parallel lines do not converge in reality. Yet, Peabrain insists that we treat this convergence of these lines as an actual fact of reality, as if these parallel lines do converge in reality. Now, I'm not here to pick on Peabrain, because obviously it seems to me that there's a lot of mathematical and geometrical concepts that he simply doesn't understand yet. If he looked into it a little further, he would probably see why he's wrong on this video. At least I hope so. So the bottom line here is just for Peabrain here that, like I said, perspective is a visual thing. It is actually something that we mostly use in arts when we want to sort of represent depth of something on a flat paper. So now that we are armed with a hopefully firm understanding of at least a way to describe perspective, let's take a look at why perspective doesn't work for flat earthers. So when you ask a flat earther of something, if you want him to explain something, chances are quite high that you will be given a YouTube video and a host of different memes. And a lot of these memes applying this perspective idea can show you why train tracks seems to converge in a straight line when you look at it from the front. But obviously, if you look at them from the top, they are still parallel all the way down to the end of the track. And that is basically correct. The problem is the way flat earthers then apply this knowledge. So one of the arguments that I have encountered a lot of times actually is the idea that perspective makes, for instance, the sun go down or a boat to disappear bottom up. And the problem with that argument is that they sort of say, well, you know, when you have perspective, then it seems that the bottom, that is the ground or the sea, seems to be rising up, and the sky seems to be converging down towards this single point, the horizon. And while that actually is true, hopefully you can see what the problem is here. If perspective really is making the ground or the sea and the sky converge to not a point, but a line, then why wouldn't that also apply to a boat? And the fact is, if the earth really was flat, if the earth was a flat plane, even if you take the little bumps and the hills and the waves and all those things, if you look at the earth itself and you imagine that it was a flat sea all the way out, perspective would indeed make that boat, that sea, and that sky seem to converge in a straight line or point all the way along the horizon. But it would apply equally to the boat, the sea, the sun, the aeroplanes, and all those things. Another problem is that for some reason, flat earthers seems to think that this convergence is apparently only working in one direction. So it will make the boat smaller like this, but apparently it doesn't make it smaller like this. And I find that to be a bit strange. If you look at videos, for example, this recording here that I have found on YouTube, you can clearly see the boat going outwards, disappearing bottom up. But if you look at it, if you imagined for yourself that this was because of perspective, don't you wonder why it is that perspective only make the boat disappear like this and not like this? Because again, if I take this Lego man here again and then slowly move him away from you, then the change in size on this direction here, this scale here, might not be as apparent at this scale here because he is taller than he is wider. Hopefully you can see still that he actually is changing his size in both directions. Otherwise we could do it like this, hold him like that, and then try again. And hopefully you can see that the Lego man is now changing size in this direction as well. And of course that makes perfect sense, because there's nowhere, when you look at the rule of tangent, for example, that direction is relevant. So the change in size is in all directions, both in the x, also in the z-axis, but the problem is that we don't see the z-axis in that direction. But if you flip that around and saw it from the other direction, you would see that z-axis, which would now be your y-axis, change its size again. But nevertheless, definitely in the x and the y-axis, we should see a change in an equal change in size, actually. And finally, then we have this problem with the sun. If you calculate how big the Earth should be as a flat disk, and you can do that, you can estimate it. And then you try to calculate how far away the sun should be if it were in fact hovering above this flat disk and moving away from us when the sun sets. You would probably calculate, even if you probably find, if you use the tangent rule, or for that matter the parallax rule, you would find that the sun had to go way beyond the borders or the edge of this flat Earth in order for it to change its angular size enough that it is less than the resolution of the eye. Now, I think the resolution of the eye is something like 0.6 arcsec. But there are two more problems with that argument, other than the fact that the sun had to go way beyond the edge of the Earth. The other problem with that argument is that if we look at the night sky, if we look at sort of a basic flat Earth model, we have the sun and the moon spinning around in the middle of the Earth within this dome or whatever it is. And then we have these little tiny dots that is supposed to be the stars on the dome. Whether it's light from outside the dome shining through holes, or it is actually lights on the dome, there doesn't seem to be one simple explanation, one general explanation for that. But fact of the matter is that these tiny dots are smaller than the sun on the flat Earth, and they are further away, yet we can clearly see them. I have heard some flat earthers argue that the reason why the sun disappears when it gets too far away from us is because that it is blocked by too much atmosphere and that we can no longer see it. The problem with that argument is that the sun is shining a light, the stars are shining a light, and yet we can see the stars even just above the horizon. Yes, they are flickering a lot because there's much movement, much turbulence in the atmosphere that the light has to go through, but nevertheless we can see them. So the problem really is here that even if the sun could go that far away from us, that its angular size became less than the resolution of the eye, we would still be able to see the light, because we're able to see the light from the stars. And the third problem with that argument, the sun is going down because of perspective, is what we have already discussed. If perspective works to make the ground, the sea, and the sky converge to a line, then it will also make a boat converge to that line equally in all directions, and it would also make the sun converge to that line equally in all dimensions. So there's no way on a flat Earth that the sun could go below the horizon unless there was something on the horizon rising up higher than our angular view to the sun. Like for instance, if you look at a building and you look at a plane can go below that building if the apparent height of that building seems to be higher than the sun. But for instance, if you look at a sunset on the sea, where there are no things taller than the height of the sun, even the apparent height of the sun, then you wouldn't be able to explain how the sun goes down. So, what is the conclusion of this video? The conclusion is that even though flat earthers to some extent get the idea of perspective right, they don't apply it in the correct way. And they apply it in such a way that they think that perspective is a scientific argument, even though science doesn't use perspective. I have never ever, in my 5 years at the university, used perspective just once as an argument. And that is being that I have spent a good deal of the time at the university dealing with astronomical phenomena, where we definitely look at things of different sizes at different distances. But we don't use the argument of perspective. We use angular size, or we can also use apparent size. And that is really what is going on here. The basic thing with perspective, as flat earthers know it, is the change of apparent size due to change in distance. That is, if you want to surmise what perspective is in a single sentence, that is it. The change of apparent size due to the change of distance. But that apparent size doesn't change reality, and it applies to all objects that you look at. Not just the ground, not just the sea, not just the sky, but everything that you look at, and equally in all directions. If you take all that, and surmise it into one single idea, then you can quickly see where many flat earthers go wrong about this idea of perspective. So I hope that you have learned something by watching this video. I hope that if you are a non-flat earther, you have sort of gotten some good arguments that you can use when you discuss with flat earthers. If you are a flat earther, then I would like for you to watch this video again, and please try to accept what I say in a basic way, in a logical way. And then hopefully you can arrive at the same conclusion as me. If not, then at least I tried. And also, please remember, if you like the video, then give it a like down here. If you don't like it, then give it a like down here. And if you have questions or comments, then please make them down here. Keep it civil, keep it respectful. And if you have scientific questions that you want me to answer, something that you think is interesting, then please also give them in the comments below. Then I will do my best to try to answer them. Remember that many scientific questions needs to have a little research done in order. It's not just shake and bake answers, but I will really try to do my best to make more videos where I answer some of your questions, particularly if it is astronomical, astrophysical questions, but also general questions about physics. I would like to try to answer those as well. And also I will continue this series of videos trying to address some of what I call misconceptions of flat earthers. Hope that you have enjoyed this video, and see you in the next one. Bye bye.